If I told you that the Earth came within an air's breadth of disaster in May 2024, would you believe me? We experienced a global Carrington event, and this storm could have been fatal for our culture in a matter of minutes. This time, we got off lightly. The G5 event only caused minor regional damage. It was a different story around 200 years ago when a huge cosmic shower of particles hit the Earth. Back then, fires broke out, and people thought that God's punishment had come upon them. Today, we already know a lot more about gigantic solar storms that can attack and destroy power lines and communication systems. We know that the danger is not over yet. It's a fact that at the beginning of May 2024, the Earth experienced one of the strongest geomagnetic storms of the last 2 decades. Triggered by violent solar flares and coronal mass ejections, huge streams of particles drifted from the Sun towards our globe. These geomagnetic storms raged in the deeper layers of the Earth's atmosphere between May 10 and 15. The particle streams were caused by the active sunspot AR3664, which is one of the largest solar anomalies we humans have ever observed. Scientists have been warned because this spot already has the potential to trigger a new Carrington event. If the spot continues to grow, which we must currently expect, the danger will become ever greater in the coming months. The all-destroying storm could hit the Earth. The stream of particles from the Sun that hit us in May 2024 led to spectacular auroras that were visible in unusual regions in the Northern Hemisphere. The northern lights were seen far to the south in some regions of Europe, and the night sky glowed reddish even in Hawaii. People saw the spectacle, and in the Southern Hemisphere, the light shows were visible as far away as Queensland in Australia. The impressive auroras were caused by the interaction of charged particles of the solar wind with the Earth's magnetosphere. Scientists watched the events with as much attention as governments, satellite operators, power companies, and the heads of the world's leading communications providers. The intensity of the geomagnetic storms was unprecedented and comparable in intensity to the famous Carrington event of 1859. Only this time, we had hardly any damage. It was different in 1859 during the Carrington event. Electrical systems went haywire, and the sky was ablaze even in broad daylight. One thing is for sure, the storms in May 2024 reached geomagnetic levels G4 and G5 on the 5-level scale, which means they were severe to extreme geomagnetic storms. Solar storms have had a severe impact on Earth and humanity. At any time, a solar storm can suddenly paralyze satellite-based communication and navigation systems and plunge our civilization into chaos. This time, we were lucky and only experienced brief power outages and disruptions to the power grid in some regions. Elon Musk posted a diagram showing the load curve of his Starlink satellites clearly reaching the limit. All in all, however, the SpaceX CEO was relieved that his satellites were able to withstand the enormous load. However, we are still far from certain as there will be more storms to come, and the AR3664 sunspot may still be active for months to come. A sunspot 15 times bigger than the Earth, how would you react if a monster suddenly developed before your eyes and you knew that this something posed a great danger to the entire globe? This is exactly what happened to scientists who observed the growth of sunspot AR3664 over a period of weeks. Sunspots are phenomena on the surface of the Sun that appear as dark and relatively cool areas. They are caused by intense upheavals inside the Sun. Magnetic upheaval leads to reversals and overlaps in the solar currents, and convection processes prevent the ascent of warm masses from the interior of the Sun. As a result, huge regions collapse on the surface of the Sun. In May 2024, the sunspot AR3664 reached a size that would have swallowed our Earth 15 times over. The lack of hot mass on the surface and the drop in temperature caused the Sun to cough, spitting out huge streams of particles that can hit the Earth in less than half an hour. The consequences of coronal mass ejections are far more powerful than such coughs. In these events, the Sun ejects entire parts of its shell, and the streams of charged particles are then more massive but also slower. Storms generated by coronal mass ejections take between 1 and 3 days to reach the Earth. AR3664 is definitely an event of the century. The sunspot is one of the largest since the beginning of solar observations, and it could continue to grow. The storm of May 2024 can only have been a harbinger. The most active solar cycle will hit us. Can you imagine the incredible forces that are being put into action on the Sun? The force of the processes is enormous. Billions of tons of plasma are circulated in a sunspot like AR 3664 alone. Compared to the entire size of the Sun, the spot is small, but it can be fatal for us Earthlings. Yet we need this activity of the Sun, and we also need its particle streams. They contribute to our climate. The Sun's light sends us vital warmth, and the Sun's particles protect us from cosmic radiation. Solar storms are cyclical. The Sun has storm seasons similar to certain geographical regions of the Earth. Just as the tropics can be hit by cyclones or hurricanes sweep across the American continents, our Sun also experiences periods when it produces massive storm events and corresponding threats. The current large sunspot is part of solar cycle 25, which repeats approximately every 11 years. Within these cycles, solar activity fluctuates from a minimum to a maximum and back again. Solar cycle 25 began in 2019 and reaches its peak in 2025. For this reason, we must expect the size of AR 3664 to continue to increase and the danger to rise. AR 3664 formed from 16 individual spots that suddenly merged into one. Typical sunspots can have a diameter of around 16,000 to 160,000 kilometers, but AR 3664 already extended over more than 2,000 kilometers in May 2024. We currently do not know when and where new spots will appear. Although we can predict solar events to some extent, our Sun is largely unpredictable. Just as a storm can brew on Earth within a very short time, so it is on the Sun. The intense magnetic activity of AR 3664 can lead to high-energy solar flares and coronal mass ejections. Like other sunspots, AR 3664 will change over time and eventually dissipate. Sunspots typically have life cycles of days to weeks, sometimes months. However, because AR 3664 is exceptionally large and active, its lifetime could be unusually long. Scientists are currently observing the spot around the clock. As soon as a particle stream is released, NASA issues warnings to governments, power companies, airlines, and space and communications companies. Those responsible then monitor the functioning of their satellites, communication systems, and power grids. In 1859, people were terrified when a plasma stream left the surface of the Sun and hit the Earth in less than 20 minutes. The sunspot of 1859 was also caused by intense magnetic activity, with the convection of hot plasma from the interior of the Sun inhibiting processes on the surface, forming a dark and cool spot. In England, an astronomer named Richard Carrington curiously observed these events. When Carrington heard that the sky was on fire in the USA, he put two and two together and suspected that these were powerful auroras that had reached deep into the south of the USA. The people in the often deeply religious remote areas of the US were afraid, associating the burning sky with a punishment from God and the Last Judgment. People are said to have run into the streets screaming and pleading for mercy. It took a long time for Carrington's explanation for the events to reach the USA, as almost all of the country's telegraph facilities were down. Sparks shot out of the masts, setting paper on fire in the telegraph stations, and apocalyptic scenes really did occur. The plasma stream hit the Earth unusually quickly. Today, experts suspect that the intensity indicates a coronal mass ejection, which was then propelled very quickly towards Earth. When such a stream of particles is ejected, the plasma moves through interplanetary space at speeds of hundreds to thousands of kilometers per second. Whether this plasma hits the Earth or not depends on several factors, including the direction of the ejection and the position of the Earth relative to the Sun at the time of the eruption. When the plasma cloud hits the Earth's magnetic field, a geomagnetic storm is triggered. The Earth's magnetic field normally traps the charged particles and guides them along the magnetic field lines to the polar regions. Here, the particles interact with the upper atmosphere and excite the atoms and molecules, causing the spectacular auroras. When large amounts of particles hit the Earth's magnetic field, the magnetic field can collapse, and then the particles from the Sun reach the lower regions, creating auroras in regions that do not normally see this phenomenon. When the Earth's protective shields are overwhelmed by the amount of incoming particles, the ionosphere becomes heavily ionized, which can cause interference in radio communication systems. Today, the increased radiation can also endanger the health of astronauts and passengers in high-flying aircraft. In 1859, technologization was in its infancy. The first telegraph systems were the latest achievements of this era, and the scenes of burning wires must have been scary. The lights were so bright that people could read newspapers outside at night, and in some telegraph stations, the telegraphs worked as if by magic, completely without a connected battery, moved by the force of the charged particles. Now you might be thinking that this is all a bit far away, but 140 years after the Carrington event, we received a severe warning. In October 2003, the so-called Halloween storms raged on Earth. These geomagnetic storms were the result of solar flares and mass ejections that began at the end of October and continued their destructive force into the first days of November. On October 28, 2003, the Sun had experienced one of the strongest solar flares ever recorded, classified as an X17.2 flare. This flare produced streams of particles hurtling towards the Earth at a speed of about 2,000 kilometers per second. Just one day later, another even stronger X10 class flare hit the Earth. The auroras then extended as far as southern Europe and Texas in the USA. In Sweden, geomagnetic currents caused a widespread power outage. Satellites in orbit were damaged or temporarily disabled by the increased radiation levels. Airlines had to change their routes to avoid polar regions where radiation was strongest, and GPS systems suffered significant disruption. The Halloween storms of 2003 made it unmistakably clear how dependent our modern technology is on the stability of space weather. They reminded the world that even in an age of advanced technology, the forces of the sun can have an immense impact on our daily lives.